Hello, everyone. Welcome back to a long overdue episode of Coding with Culp. I meant to have this video done really a couple weeks ago, but had a lot of stuff happen, not the least of which was Texas, where I live, was inundated with a massive, once in a lifetime snowstorm. I call it snowpocalypse or snowmageddon, and things got really bad here for a while. I know many people up north laugh that, we basically lost power. Pretty much something like 40-50% of the state lost power. It got incredibly cold in my house. We didn't have power for probably about 4 days, reliable power or water, and it got pretty cold in the house. Here inside the house, it was about 41 degrees at its coldest. In fact, we had to abandon the house and go to my wife's work where they had power. Anyways, I've been meaning to get this video out for a while, and I'm finally able to do it. So what we're going to do over the next series of videos is we're going to make a game out of Pi game, kind of a classic game, an asteroids style game. We're going to do it over a series of probably 4 or 5 videos, and let me show you what we're going to be making. And actually, it's not quite done yet. I'm going to continue working on it as we go along. But I call it space rocks because I can't call it asteroids. And another thing, I usually use the Raspberry Pi, and the Raspberry Pi is more than capable of running what we're going to do. The problem is right now, because the game has sound, the way that I record the Raspberry Pi footage, sound doesn't come through. So I'm attempting to figure out how that works or work that out. And when I do, I'll switch back over to the Raspberry Pi. I like the Raspberry Pi because, everything's easy to install. Python, Pygame, and all the tools that you need are super easy. But let's take a look. So it's just a simple asteroid-style game, as you can see. As you shoot, you can see up here, we have a amount of energy. You start out with 100. And as you get hit, that energy level goes down. It scales. Let me turn this down. It scales based upon the size of the asteroid that you hit and the speed that you hit it at. So the larger the asteroid and the faster you hit it at, the more energy you're going to lose. So I lost, I can't remember, about 12 for that one. But let's hit a medium one at full speed. And we lost quite a bit more there. It's got levels, so when you clear a level, and you'll see that the asteroids break up into smaller asteroids as you hit them, and it's actually a random number of asteroids. You also have smart bombs. I've got a cheat in there right now, so you get 400 smart bombs, but by pressing S, it automatically applies a hit to every asteroid on screen. The final game, you'll start out with like 1 smart bomb, and you'll be able to collect more as you go along. So you can see if I hit 1 asteroid, it breaks up into multiples. It's actually random. Therefore, sometimes they'll break up into 1, sometimes 2, sometimes 5. The larger asteroids have the chance of breaking up into larger or more asteroids than the smaller ones do. And the smallest ones, they get destroyed automatically. In other words, they don't break up the tiny ones. And the game gets progressively harder as you go up in level. Let me just cheat here. As you go up in level, you get more and more asteroids on each level. You do, for clearing a level, you get a tiny amount of energy. I can't remember what the exact formula I use, but it has to do with the level that you're going up and a few other things. So we cheat again. I'm about to die. So I got 2 here, 2 energy, and then when I go up, 20 energy. And you can see there's a lot more asteroids each time I go up in level. And like I said, I've got a cheat in there right now just to test things out, where you start out with 400 smart bombs. You normally wouldn't. You start out with 1. One thing I haven't implemented yet is a power-up system. So I thought I'd have power-ups where you get rapid fire, so you fire faster, maybe dual guns, of course energy that comes out, and a few other things as you go along. And in fact, because the game's not done, if you've got any suggestions for... I'm about to die. If you got any suggestions for power-ups and stuff, I can definitely see about adding that. So anyways, we've got game over there, and it's going to go back to the title screen. So that's what we're going to be doing over the next, maybe, like I said, probably in the neighborhood of 5 videos or so, is developing this game. Let me go over a few things, some expectations, some prerequisites, and stuff like that before we... Alright, let's go over what we're going to do, and then some prerequisites that you need to know before we get started, or things you need to have done. We're going to make an Asteroid-style game from scratch. I'm going to do it using very simple, very readable code. The object of this whole video series is to teach. So as I type and as we go through this, I'm going to teach. I'm going to explain the code that I am writing as we go along. And so once again, I'm going to use very simple, very readable code, especially made for beginners. Also, I'm not going to use any object-oriented programming right now. If you don't know what object-oriented programming is, don't worry about it. I will have to say that I am so used to object-oriented programming, it was actually very difficult for me to write this without using object-oriented programming. But I consider that to be kind of an advanced technique, and I know a lot of my audience isn't quite there yet. I do plan, I think what I'm going to do is once I'm done with this, I might go back and rewrite the same game using object-oriented programming techniques. Each episode, the code base may change a little bit. What I'm going to do is each episode, I'm going to have a download link for the code and the graphics that I start with, except for this one. But from here on out, there'll be a download link, a zip file, and it'll have inside the code that we start with, and then all the graphics that are needed. As we go along, like I said, my whole object is to teach as we go along. Programming is a puzzle, and occasionally some things might not make sense at first. Sometimes to understand something, you've got to learn something first. And things are a little discombobulated, a little bit confusing, but by the end, I think you'll understand everything. And I'm going to try desperately to try to keep each video to somewhere in the neighborhood of 30 to 45 minutes as we go along. Some prerequisites. Number one, you need to have installed Python 3. We can't use Python 2, you got to have Python 3. You need to have an integrated development environment of some sort, an IDE. The built-in IDE that comes with Python, idle, is just fine if that's what you want to use. I actually use one called Genie. I like it because, number one, it's free. Number two, it's super simple to use, especially for beginners. Sometimes IDEs, integrated development environments, have so many features that they get in the way of learning to program. And one thing we should never do is have our tools get in the way of our learning. You need to have installed Pygame, and I've got videos on how to do this on Windows and on Raspberry Pi. Like I said, I normally do these videos on Raspberry Pi, but because the game uses sound and the way I record the Raspberry Pi, sound doesn't come through. You don't need to know Python at all. Like I said, one of my main goals is to teach as we go along. It does help a little bit if you know a little bit, but you don't have to. Math. So games are notorious for having math in them. Most of the math we're going to be doing is pretty simple, but we are going to be using some trigonometry and especially the sine and the cosine function. If you don't know trig, don't worry about it. There's like a total of maybe 4 lines that uses trig out of right now a program that's 600-700 lines long. I am going to explain that trigonometry, so I'm going to explain it when we get to it. So if you don't know it, don't worry about it, okay? All right, without further ado, let's go ahead and let's get started. So fire up your integrated development environment, and let's get started. All right, I have fired up Genie under Windows. Like I said, you can use whatever integrated development environment that you want. I like Genie, and I'll have links down below for downloading it because, like I said, it's super simple. You need to create a directory somewhere on your file system, on your hard drive. Call it Space Rocks or whatever you want, and then make a file called spacerocks.py inside of that directory. We're going to be dropping a lot of graphics and other things in there later on, but for now, just create this single file inside that directory. What we're going to do today is we're going to make what I call a skeleton. it's not going to do much, okay? It's basically going to set up most of our variables, our constants, and it's going to get Pygame up and running and give us a window. In fact, I've got it right here, and if I execute it, you'll see that it doesn't do much. There we go. That's it. That's all it's going to do. But it's going to set the groundwork or the framework for everything that we are going to do here in just or throughout the rest of this video series. So let's get started. All right, the first thing I need to do is I need to import the libraries that I'm going to use. And I'm, of course, going to need the Pygame library. And if you don't have that installed, I've got videos on how to install it, and I'll link them below, or you can Google how to install it. We're going to need the math library, the sine and cosine, and a few of the functions we're going to use are inside of that library. We're going to need the sys library. We're going to use that to quit out of the program. We're going to need the time library. And we're going to need the random library. Now, when it comes to importing, you can actually put all these in one line. I could have said import Pygame, comma math, comma sys, comma time, etc. But it's more traditional in Python to put all your imports on separate lines. All right, what I'm going to do now is I'm going to write some what I call support functions. These support functions are going to help us out as we go along. And the first one's called clamp. And clamp's going to take 2 or 3 variables. What clamp does, what this function is going to do, oh, I called it clam. I want it clamp. All right. What clamp is going to do is it's going to take a number in, okay, and then the minimum that number could be and the maximum that number could be. If the number is below the minimum, it's going to raise it up to the minimum number. If it's above the max number, it's going to lower it to the max number. And finally, if it's between min and max, it's just simply going to return that number. I'll give you an example. Let's say, well, we have a velocity of our spaceship between 0 and 100. It can't go below 0, and it can't go below 100. So if we wanted to clamp, we did some math, and we wanted to make sure that our velocity was between 0 and 100, we would pass in, we'd call the clamp function. For in, we would pass in our velocity, and then 0 for min and 100 for max. If it was below 100, above 100, it would set it at 100. If it was below 0, it would set it at 0. And if it was between those numbers, it would just return that number. There's a bunch of different ways to do this. Once again, in my simple code philosophy, I'm going to do it in a bunch of lines of code. In reality, there's a way to do this in one line of code, but I thought it was too confusing for beginners. So if in, our number is less than the minimum number, min in. So if n is less than the minimum number, we're going to return the minimum number that it can be. I'm not doing well typing, am I? Else, if n is greater than max n, we are going to return the maximum number. And then finally, if neither one of those are true, we know it's between, and we're just going to return in. So there we go. We have a function now called clamp, and it's going to take 3 values, the number we want to clamp, the minimum it can be, and the maximum. If it's below minimum, we're going to return the minimum number. If it's above, we're going to return the maximum number. Just in case, let me run this real quick to show you what I mean. Let's say n equals 7. So what we could do is we could say clamp in and let's say we want to clamp it between 0 and 100. And now let's do this. Print in. So when I execute this, by the way, you don't need to do this. It prints 7. I don't know if you can see that there, but it prints 7. But let's say it was 700. Okay? 700. When I need to do this, I'm sorry. In equals clamp in. There we go. What that's going to do is it's going to call the clamp function and assign whatever it returns back to our variable in. All right, let's execute. And you can see, I hope, that's a 100 there, if you can't see that. So it clamped it to a 100. What if it was negative 700? If I execute it, it clamps it to 0. All right. The other function is the distance function. The distance function computes the distance between 2 points on a plane. We're going to use x1, y1, that's point number 1, an x and a y coordinate, and then x2 and y2, that's the x and y of the second coordinate. And once again, I'm going to do this in several steps. There's a way to do this in one line, but I broke it up into several steps. So the distance function is x2 minus x1 squared plus x2 minus y2 squared, and you take the square root of all that. So my x term is going to be x2 minus x1, and then to square it, 2 asterisks and a 2, and that's going to square it. Raise it to the power of 2. The y term I'm going to calculate as y2 minus y1 and square it. And then we're going to return math.sqrt. That was our math library. Okay. The square root function is located in the math library, so I got to preface it with the name of the library. So it's math.squareroot, our x term plus our y term. All right. Once again, I'm going to use it. You don't need to do this. I just want to demonstrate it. Print. Oh, geez. I forgot to put this function name. All right. Distance between, let's say, the origin, 0, 0, and a point 100, 100. So what that's going to do, is it's going to compute the distance between the origin point, 0, 0, and a point 100, 100. And it's 141.4213562 something, something, something. All right. There's another function that we need called vector magnitude. And if you don't understand what a vector is, I am going to explain it in another video in this series. But we can think of a vector kind of as 2 points, sort of. And it's going to be very similar. It's going to be, we're going to return math.squareroot. You're going to recognize this in just a second. Vector 1 squared, plus vector 2 squared. All right. So what this does is it calculates the size of what we call a vector. And like I said, don't worry, I'm going to explain it in a later video. All right. Now what I'm going to do is I'm going to do our main game loop. So let me find where I've got that on here. What I'm going to do is I'm going to do a I like to separate major sections of code with these big things right here. main game loop. I'm probably going to be doing some cutting and pasting here just a bit in the interest of time. Okay. So what we're going to do is we're going to say while game state. Game state's going to be a variable that we're going to create here in just a minute. That's going to hold basically the state of the game. Is the game currently running? Are we currently in the title screen? Are we currently in the end-game screen, etc.? While game state is not equal to game state quit. In other words, as long as the game state isn't set to, hey, let's stop the game, we're going to do this over and over and over. We're going to check Pygame events. That's going to be a function that's going to check for events such as mouse movement, joysticks, key presses, etc. It's something I forgot to mention. The game does work with joysticks, and you'll see that in a bit. So now, if game state equals game state running, so the game is currently running. In other words, if the game's actually in a game, we're going to do these things. We're going to draw scene. Draw scene does exactly what it says. It's going to draw the current state of the game. And then we're going to do pygame dot display dot update. Pygame.display.update, you have to call all your drawing, or all the drawing that we're going to do is going to be done to what we call a background buffer, and it won't be displayed until we call update. So we're going to do all this drawing in the background, and then when we call update, it flips it to the front. All right. Else if game state equals game state title. In other words, if we are in the title screen, we're going to run a little function called title screen. And then once again, we're going to do our pygame.display.update. And then else if game state equals game state paused. In other words, if our game is currently being paused, which I forgot to show you, you can actually pause the game. In fact, let me go over to that and I'll show you. I press P to pause, and the game's paused. I don't have my fingers on anything. I press U, it unpauses. One other cool thing about the joysticks is it's analog in nature. So if you have an analog stick, pressing the stick just a little bit causes your ship to accelerate just a tiny amount. And if you press it a lot, it causes your ship to accelerate a lot. All right. We're going to lock this to 30 frames per second. That's what this clock.tick does. So basically what happens, it starts out at the top of the loop, runs down through the bottom of the loop. When it gets to here, it's going to wait and make sure that we're not going past 30 frames per second. All right. And this is what happens if we exit the game. Print. Thanks for playing. Pygame.quit. And then sys.exit. Okay. So that's our main game loop. This won't run right now because we've got some stuff that we need to define, but we'll do that in just a minute. Let's write our check Pygame events function. Some people like to do this checking for Pygame events right in the main game loop. I don't actually like to do it. In fact, I like my main game loop to do nothing but call functions. That's all I wanted to do. I don't like to do any processing or any game logic inside of the main game loop. I like my main game loop to be clean. That's not always possible, but in this game it is. So I've got a function called check Pygame events. And so we're going to check Pygame events throughout, each time we go through. Whew, man. All right, we're going to be modifying a global variable that we have called game state. So we need to tell it, hey, this variable we're going to be modifying, game state, it's actually a global variable. If we don't do this, when we modify game state, nothing's going to happen inside of our global variable. And you'll see that in just a bit. All right. So the first thing we're going to do there's a number of different ways to check key presses in Pygame. I like to do it this way. Some people don't. What we're going to do is we're going to call this function pygame.key.getPressed. And what it's going to do is it's going to load up this variable keys with the state of every single key. Okay, it's basically a list of every key and their state, whether they're pressed or unpressed. We're also going to do that with events. We're going to say event equals pygame dot event dot poll. Now we're going to say if event dot type equals pygame dot quit. Okay. In other words, if we want to quit, and that should not be capitalized. We're going to set our game state variable. And we're going to set it equal to game state quit. Now we're going to define all of this in just a minute. Okay, we're going to define what game state quit and all this other stuff means in just a minute. And then if keys pygame.k escape game state equals game state quit. So essentially what this is doing, if Pygame gets an event type of quit, we're going to set our game state variable to the value of game state quit. Like I said, we're going to define all this stuff in just a minute. Or if keys, remember that keys list, if the pygame.k escape key is pressed, we're also going to set our game state to game state quit and then quit. All right. Now we've got a function called draw scene. I cannot type or spell. All right. Draw scene is where we're going to draw everything. Okay, so the first thing we're going to do is we're going to draw a black rectangle. And that black rectangle, if you see it in the game, let me show you the game real quick again. It is, believe it or not, it's this rectangle up here. It's this black area right here where we're going to put all of our information, score, level, number of smart bombs, that sort of stuff, and ship energy level. So we're going to draw that rectangle. So what we're going to do is we're going to make a rectangle object. We're going to call it rect. We could have called it anything we wanted to. And we're going to set it equal to pygame.rect. This is how we create a new rectangle object to draw. And the first thing we're going to set is the upper left-hand corner of that rectangle. The upper left-hand corner is going to be 0, 0, the coordinate 0, 0. So graphics coordinates up here in the upper left is 0, 0. The x coordinates get bigger as we go to the right, and the y coordinates get bigger as we go down. So this is 0, 0, and I think this down here is 900, 900. Actually, be 899, 899, because I think we did 900 pixels by 900 pixels. All right, and then what we need to do is we need to set the width and the height of the rectangle. The width of the rectangle is going to be our screen width. And once again, this is a variable we have not set yet, but we will in just a minute. And its height is going to be 31 pixels. Now we draw the rectangle with pygame.rect.draw. And the rectangle draw function takes a number of different parameters. The first one is what we want to draw to. We're going to draw to our screen device. And once again, that's a variable we haven't created yet, but we will in just a minute. And we're going to do it in the color black. That's once again a color that we're going to do and define. And we're going to draw the object we want to draw is this rectangle, okay, that we defined, rectangle. All right. Let's continue on. Now what we're going to do is we're going to draw our status text. Actually, you know what? We're not going to draw that right now. What we're going to do now, we're going to define a couple of dummy functions. One's called title screen that doesn't do anything right now. Nothing. Okay. Title screen. And for title screen, we're just going to do pass. And what pass does literally means don't do anything. We have to have that pass. We can't have an empty function in Python. And then we're going to do one called game paused. And this is the function that we will execute if the game is paused. And right now it's not going to do a single thing. Okay, now we're going to get to defining all of our game setup stuff. So once again, what I'm going to do is I'm just going to copy and paste this. Programmers are lazy. If we can get away with copying and pasting, we will. And I'm going to call this game setup and variables. All right. Bring that back into there. So this is where I'm going to define all of my variables and stuff such as that. I'm going to do a little cutting and pasting from my other programs. Give me just a sec. Okay. So first thing we're going to do is we're going to set up colors. And if you need to get caught up, you can always pause the video. In Pygame, colors are three numbers, a red, a green, and a blue value. And so those values range from 0, meaning none of that color, to 255, which means full that color. So brown, we got 193 red, a lot of red, about a medium amount of green, and about a third the amount of blue. So this is the red, the green, and the blue value to make up brown. Black is 000. Red, pure red is 255.00. Green is 255.0. No red, full green, no blue, etc. All right. Now we're going to set our screen width and our screen height. We're going to use a 900 pixel by 900 pixel display. And so these are variables that are going to hold it. Okay. Next, we have, we're going to set up or initialize Pygame and set up the drawing window. This is for sound, pygame.mixer.preinit. And it takes a number of parameters, the frequency that we want to initialize our sound setting to, and these are the most common options. Right now I've got it commented out, and you can too. Okay, it's not always needed. Sometimes it is, sometimes it's not. But it's frequency, size, number of channels, and the buffer size. And for most things, we don't ever have to worry about it. So I commented it out, and we could probably get rid of it. All right, pygame.init. Before we can do anything with Pygame or call any type of Pygame functions, we have to initialize Pygame, and that's what this does. Pygame.key.setRepeat. Okay, what we're doing here is we're setting our repeat rate for our key. If we don't set up key repeat, what's going to happen is that when we press the key, okay, it will register as pressed, but won't continuously repeat. We're going to set up a clock object. This clock, this Pygame clock, is going to keep track of our frame rate. Remember down here, we used it to clock.tick30, so that's going to keep us at 30 frames per second. All right, I've got two different ways to make fonts here, and we're actually going to use the one that I have commented out with the hashtag. By the way, that's how you make a comment in Python. It's the hashtag. And what it does is it's just a comment for us programmers. It doesn't actually, do any type of code. We're going to set a variable called font. I could have called it anything I wanted to, but I just decided to call it font because, well, that's what it is. and we're going to call pygame.font.sysfont. What sysfont does is it looks for a font named this, which I'm going to use Arial because pretty much everybody has Arial on their system, and a size of 28. And this is what I use to draw all of the game stuff in up here. So that's this right here. Now that's not Arial. I actually use what we call TrueType font for that. I'm going to explain that in just a second. I actually am going to give you a graphic file or a font file that will be used later on. But for now, for today, we can just use the default font. And I've got it commented out. Font equals pygame.font.font, and we pass to it a file name. So we're going to use this Zork or Zorq, I don't know how you pronounce it, .ttf, and that stands for a TrueType font. Once again, 28 point, and we're going to set bold equals true. We're going to make it in bold. And then finally, last thing we do in this section is we're going to set up our screen object. I could have called this anything. I could have called it screen. I could have called it display. I could have called it video_display, anything I wanted to. But what it does, pygame.display.setMode, set_mode, it takes a screen width and screen height. Notice it's in brackets. That's important. Okay? Notice that it is in brackets. So it takes a screen width and screen height. Now I could have hard coded this. I could have done it this way. I could have said 900, 900. But I don't like to hard code things. What if later on we decided, hey, let's change that. Let's make it 600 by 600 or 1024 by 900. And we're going to be using the screen width and screen height in a lot of different places. Like we already used it up here. Okay, we already used it up here to determine how wide the rectangle we draw at the top of the screen is. And so if we hard code that, we're going to have to go change it in every single spot. So I don't like to do that. And you know what? I'm going to get rid of this. We actually don't need this pygame.sourceAlpha. That was something I was experimenting with. So I'm going to get rid of it. All right, let's go to the next section. Okay, here's the next section. We're going to initialize joysticks. Like I said, this is going to use joysticks. So we're going to call pygame.joystick.init, and that's going to initialize any joysticks you might have plugged in. We're going to get the count. How many joysticks do we have? Okay, because we need to keep track of that. Because really what we're going to do is in places where we're going to check for joysticks, we're going to see if that count number is greater than 0. And so we will know that they've got a joystick plugged in. And so basically what we do is we call pygame.joystick.getCount. And then we're just say if joystick count is greater than 0, we're going to create a joystick object. And I called it joystick. Now, once again, it's confusing because I could have called it anything. I could have called it joy. I could have called it joystick. I could have called it controller. This is just a variable. That's it. Nothing more. And what this does, pygame.joystick.capitalJoystick0 is going to get the first joystick. Joystick number 0. I know that's confusing because it's the first joystick, but it's joystick number 0. And assign it to our joystick. Okay. Then we're going to initialize that joystick. And I know it's confusing because we did some joystick initialization up here. But really what this does is it initializes the joystick subsystem. And what this does is it initializes a single joystick that you found. Then what I'm going to do is I'm going to print it out, name equals joystick.getName. And then I'm actually going to print out that joystick's name. And, well, I've got a joystick right here. Let me plug it in. Well, let me run the game twice, okay? One without the joystick and one with the joystick. So let me come over here. So you'll notice nothing gets printed, if you can see this. I know it's kind of small, about our joystick because I don't have one plugged in. But I'm going to plug in this Logitech F310. If I can find my USB port. Okay, there we go. All right, now let's run it again. And I think you can see that. Joystick name, controller, gamepad, F310. Because like I said, this is a Logitech F310. And I can actually play the game. I can press start, and it's going to start the game. There we go. And I can play it. Once again, pressing the joystick forward just a tiny bit, I accelerate slowly, or I can accelerate quickly. It's actually kind of a fun game. Anyways, let's go ahead and quit. Alright. So that's what that does. Alright, let's go to the next section. Alright, here's the next section, and it's quite long. What we're going to do here is we're going to set a ton of variables and constants for everything that's in the game. So the first thing we're going to do is we're going to set up the player and ship variables and information. So that's all this right here. Now I do have these two lines commented out because we haven't loaded any graphics, and these have to deal with the graphics. Okay, current ship image equals ship image no thrust. We're going to load in some ship images, one for the ship and then one for the ship under thrust. If you notice, a little bit of fire comes out of the back, and we haven't loaded those yet. And I don't have a download link for you to load them until the next video, because that's what we're going to do in the next video. All right, then same thing. We're going to create a rectangle object from the ship image. Ship image no thrust.getRectangle. All this does is it makes a rectangle object, okay, for our ship, and it's going to keep track of the X and the Y and the width and the height of the ship and stuff like that. We'll get into that later on. All right. Ship angle equals 0. That's the angle of the ship. As you notice, the ship turns, so it's going to have an angle from 0 to whatever. Ship delta X. That's the speed of the ship in the X direction, how fast it's going horizontally. And then the ship delta Y is the speed of the ship, or how much the ship's Y position changes. And delta is a common name for change. So how much is its Y variable changing? And once again, we're going to set both of those to 0. Ship friction. I don't know if you noticed this, but the ship actually slows down over time. Let me go back to here and run it once more. The ship will actually slow down. So I'm going to get it going fast, and then I let go, and it slows down over time. And what that ship friction is going to do is it's going to control how fast it slows down. Acceleration, same thing. It accelerates slowly over time, and this basically controls how fast it accelerates. The ship energy is the amount of energy. When you get down to 0 energy, game's over. Number of smart bombs that you start out with. Once again, I did a cheat with 400 because I was testing out a bunch of stuff, but normally we're going to start out with 1 smart bomb. You can make the game easier by starting out with 2 or 3. All right, last smart bomb time. We don't want the user to be able to spam smart bombs over and over again. And so what we're going to do is we're going to keep track of the last time that they launched a smart bomb. And we're going to do that in a few different places, you'll see. And we're going to check and see if more than 1 second has gone by. And if so, then they can launch another smart bomb. If they press the S key for smart bomb and less than a second has gone by, or 2 seconds, or whatever we determine, it won't launch a new smart bomb. And then, of course, the game score, 0. All right, missiles. So we're going to keep missiles, every missile that the player fires, in a list, and we're going to call it missile list. Okay? Shot time. This is the time between successive shots. How fast the player can spam the fire button. Right now, it's set at 0.25, or about 4 shots per second. We can turn that up or down depending upon how hard we want the game. And like I said, if we do power-ups, one of the power-ups is going to be to drop that that shot time down lower so you can spam faster. All right, and the same thing, last shot time, we got to keep track of the last time that they shot so that we can check to make sure more than a quarter of a second has gone by. All right, now what these right here are, our missile list is really going to be a list of lists. Inside of the missile list is going to be missiles, and each missile is going to have a speed in the X and the Y direction, okay, and their rectangle, the actual missile's rectangle. I'll explain this as we get to it, okay? I know it might be a little confusing right now. But essentially, this tells us that element number 0 in that list is going to be the X position of that missile. Element number 1 in the list is going to be the Y position. And then element number 2 in the list, 0, 1, and 2, 3 things, is going to be the rectangle object that keeps track of the X and the Y and the width and the height of that missile. Asteroids are similar. Okay, we're going to have an asteroid list, and each list, or the asteroid list, is going to be lists of lists. So each asteroid is going to have a speed in the X and Y direction, a rectangle object to keep track of its X position, its Y position, and its width and the height. And then a size. So you notice we had 3 different sizes, and so it's going to hold whether it's a small, a medium, or large. Its rotation angle, okay, you know, what is its angle that it's rotated at, and then its speed, okay, how fast is it moving across the screen. All right, and then for asteroid size, once again, we're going to have an asteroid large, asteroid medium, or asteroid small, and we're going to set this right here, asteroid size, to either large, medium, or small. Like I said, I know a lot of this isn't going to make sense right now, but it will once we get into the meat and potatoes of what we're doing. All right, constants to track game state. Game state title. Remember that down here where we're like, hey, well, game state is not equal to game state quit, or game state is not equal to game state running, etc., etc. This is where we're going to do all that. These are just variables. Okay, game state title is going to be equal to 0. Game state running 1, game state end 2, game state pause 3, game state quit 4, game over 5, level over 6, etc. And then we're going to set our initial game state here. Initially, we're going to set game state equal to title. Okay, game state is going to be initially set to title, and we're going to start out at game level 1. This is where we're going to keep track of our game level. All right, finally, we're at the end. Then we can run this thing. You can see that it doesn't do much yet. Explosions. Same thing. We're going to have a bunch of constants. Okay. Each list or each explosion. Okay. Those lists that keep track of an explosion. Element number 0 is going to be the image of the explosion. Element number 1 is going to be its rectangle. Element number 2 is its dx and dy, speed in the x and y position. The explosions, as you'll notice, have different frames for their animation. Oh, I'm running the wrong thing. The explosions have different frames, as you'll see. And so we got to keep track of what frame number we're on. And so that's what this is going to do. Element number 4 in that list is going to keep track of what frame we're on. The last frame time. Basically what we need to do is we're going to switch frames like only every tenth of a second. So we need to know what the last frame time was. And then the explosion size. You'll notice we have small, medium, and large explosions based upon the size of the asteroid. All right. We also set explosion small equal to asteroid small, explosion medium equal to asteroid medium, and explosion large equal to asteroid large, because they're going to correspond to small, medium, and large asteroids. And then finally, we have the explosion list, and the explosion list is going to hold every explosion in the game. All right, so that's it. That's our skeleton. It's set up. It's ready to go. If we run it, you'll see that it really doesn't do much of anything. It sets up our window, and that's it. So next video, what we're going to do is we're going to load in our graphics, and we're going to start putting stuff onto the screen. I think next video, what we might do is load in the graphics and then go ahead and possibly put either the player on the screen or the asteroids on the screen. In fact, why don't you comment down below, tell me what you want next. Controllable player or the asteroids moving around the screen. Let me know. Also, I forgot to mention, really would appreciate it, if you subscribe to the channel and like the video, especially if you want to see us play out. I plan to do a lot of games like this, very simple games, and then explain how they work. Like I said, some of this might be a little confusing, but as we get into the meat and potatoes of actually coding, it's going to make a little bit more sense. So, thanks a lot, and I'll see you in the next video. And as always, today was a great day to learn how to code. Bye-bye.